This topic, refraction of the light, the question related to the topic. We did this topic last week. So in the first question, when an incident ray of a light meets a boundary between the air and a glass, you can see here the light incident ray strike air and glass boundary. Some of the light is reflected and some of the light is refracted, as shown. The reflected light is partially plane polarized. What is the meaning of plane polarized? For example, the light which is unpolarized light will have multiple component of vibration. But the plane polarized is the light which is having only one component of a vibration that we called as a plane polarized light. So what is the definition of a plane polarized? So vibration or oscillation are in the same plane or in one plane, or vibration or oscillation in one direction, and that is perpendicular to direction of wave travel. So the definition for polarized light or plane polarized light, direction or vibration or oscillation in one plane. If you use the term plane, that time, like in that definition, if you are using the term plane, you have to use that which include the direction of wave travel. But if you are using the term direction, like if I'm using the term direction, the same definition I'm writing for polarized light and use the term direction, that the vibration or oscillation in one direction. So if you use the term direction, which is perpendicular to direction of wave travel. So two things are there. If you use the term plane, that you should complete the definition by mentioning which include the direction of wave travel. And if you use the term direction only, like vibration or oscillation in one direction, and that are perpendicular to direction of wave travel. The next one, deduce whether the refracted ray is unpolarized or partially plane polarized. So what happened? We have to deduce whether a ray, refracted ray is unpolarized or partially plane polarized. So how we can identify this? So normally, if the partial reflection and refraction occur, if the reflected ray is polarized, if the refracted ray is polarized, or reflected ray is polarized, refracted ray is also polarized. Or the refracted ray is not having too many planes of vibration, like it cannot vibrate in many planes. That is why it must be partially polarized. Or not too many space available for the refracted ray to vibrate. So refracted ray is also partially polarized. And what is the reason for that? Why it is partially polarized? Because not many planes available for vibration. That's why it is partially polarized. Like there's a limited planes available for a vibration to happen or occur. In part C, at the Brewster angle, which is theta b, the reflected ray is completely plane polarized, and this occurs when the reflected ray and the refracted ray are 90 degree, so they have an angle 90 degree between them to each other, so that the Brewster angle plus r, like Brewster angle plus r is equals to 90, like sum of them will be equal to 90. We have to show that the tangent theta, refractive index of a glass divided by refractive index of tangent theta b is equals to refractive index of a glass divided by refractive index of air. This is what we have to show. So we have the formula n1 sine theta 1 is equals to n2 sine theta 2. Like the refractive index of medium 1 is n1 and angle in medium 1 is theta 1. Refractive index of medium 2 is n2 and angle of in medium 2 is theta 2. So according to Snell's law, it is n1 sine theta 1 equals n2 sine theta 2. What is n1? N1 is the air, like the refractive index of air, which we call Na, and theta 1 that is equals to theta b. So this one is Na, the refractive index of air, and sine, this is theta and b. Then refractive index of medium 2, that is a glass. This is a glass. The refractive index of medium 2 is the refractive index of a glass, and sine. What about theta 2? So this will be theta 2. So theta 2 is equals to r. So in place of theta 2, I can write r. And what about the value of the r? So r is equals to 90 minus theta b. So when we simplify this, like in place of r, I can write 90 minus theta b. So refractive index of air, then angle in that medium divided by equal to refractive index of a glass, and angle r, which is 90 minus theta b. And what is sine 90 minus theta? When we simplify this, sine 90 minus theta is equals to cos theta. Like if there is sine 90 minus theta, what we'll get? We'll get the value for cosine theta. This is a trigonometric formula relation. So we can say Na sine theta b equal to refractive index of a glass, and sine 90 minus theta is equals to cosine theta b. When we simplify, cos theta is multiplied, other side will be divided. So it will be sine theta b divided by cosine theta b is equals to refractive index of a glass divided by refractive index of air. And again, another trigonometric ratio, like sine theta divided by cosine theta is equals to tangent theta. So sine divided by cos is equals to tangent theta. So it will be tangent theta b is equals to refractive index of a glass divided by refractive index of air. So we show this by formula, like we derive this formula that tangent theta b is equals to refractive index of a glass divided by refractive index of air. Is it clear, this derivation?
Yes.
The next part, we have to calculate, we already derived a formula that tangent theta b, we already derived that tangent theta b is equals to refractive index of a glass divided by refractive index of air. They give us the refractive index of air and the glass, so we just substitute, this will be 1.5, this is 1, and tangent theta b. But we need theta only, so theta b is equals to 10 inverse 1.5. So we'll take an inverse, 10 inverse of 1.5. This will give us, and remember, whenever you, the mod of your calculator should be in degrees. So it will give us 56 degrees. That's the angle. So we just use the formula and work out the angle. Different colors of a visible light are refracted as they pass through a prism. As you can see, violet bends the most and red bends the least. A student suggested that a Brewster angle for a violet would be smaller than for a red, as a violet refracted more than red. Criticize this suggestion, like whether this suggestion is right or wrong. So as you can see, When these ray of a light, like white light, which is a combination of 7 color, violet is there, indigo is there, blue, green, yellow, orange, and red. But you can see the violet bends the most, and red bends the least. So it means the refractive index for violet, because violet is bending more, so it means the refractive index of a glass for violet is higher as compared to refractive index for red. Red is experiencing a smaller refractive index of a glass as compared to a violet. That's why violet is bending more and red is bending least. And we have the formula that tangent theta B is equals to refractive index of a glass divided by refractive index of air. Refractive index of air is not changing. So it means we can say that tangent theta B is proportional to refractive index of a glass. Means if a glass is having a higher refractive index, or a light which experiences a higher refractive index of a glass will have a greater angle or Brewster angle. So the student suggested that the Brewster angle for violet would be smaller. So when we criticize this suggestion, so it means student suggestion is incorrect. Why? Because violet is bending most. It means the violet experience greater refractive index of the glass. As it experiences greater refractive index, then theta B should be higher for violet as compared to red. Is it clear, this third part?
Yes.
In question 2, we have a variety of colors is often seen when a white light is reflected from a thin layer of oil on a puddle of water, and the light reflected from a top of this layer of oil undergo a phase change of 180. This results in a phase difference of 180 between the reflected light and the incident light. Explain what is meant by phase difference of 180. So phase difference of 180, what does it mean? It means like two waves are out of phase by, or they have the part difference of lambda by 2, or when they interfere, they will have a destructive interference. So phase difference of 180 means that the part difference will be half of the wavelength, or wavelength divided by 2. And there will be a destructive interference. So if one crest is joining, the other one trough will join. So they will cancel out the effect of each other. As a result, they will have a destructive interference. The diagram shows a thin layer of oil of thickness D. On the surface of a water, a ray of a white light is incident on the oil. As you can see, this ray of a white light incident on the oil. Some of the light is reflected, which undergo a phase change of 180, and remaining light is refracted. Then it bounces back. And like what happened, if this is a wave, crest hit, so then trough is going out. But the wave which discontinue, and the two waves will have a 180 out of phase. That's why destructive interference is there. The light reflected from a bottom surface does not undergo this. This does not go under a phase change. Only this one undergo a phase change. Calculate the velocity of a light in oil, and the refractive index of the oil is 1.5. Remember the refractive index of the air, which is, we always consider that refractive index of air is 1. So we have the formula here. We don't have the angle, and we know the refractive index and speed are inversely proportional. Like higher refractive index, smaller speed; smaller refractive index, higher speed. So here the velocity is v1. In the oil, the velocity is v2. We want to calculate speed of light in oil. So when two quantities are directly proportional, their product is constant. So N1 V1 will be equal to N2 V2. N1 is a refractive index of the air, which is 1. multiplied by speed of the light in air, that is a fixed 3 exponent 8 meter per second or 3 exponent 5 kilometer per second. So this will be 3 into 10 power 8. Refractive index of the oil, that is 1.5. And speed in oil we don't know, so we say V do. 1.5 is multiplied, other side it will be divided. So it will be 3 into 10 power 8 divided by 1.5. So when we simplify, it will come out as Q into 10 power 8 meter per second. That's the speed of the light in oil. In question 3, an endoscope in medical device that can be used to see inside digestive system, inside the digestive system. The endoscope contains bundles of very fine glass fibers or optical fiber. The light is directed into the fibers and to eliminate the part of the digestive system is investigated. For example, checking the inside the stomach. So this endoscope is there, which is used, an endoscopy is used. So light will undergo multiple time reflection, which we call total internal reflection, as the angle of incidence is more than critical angle. State the condition required for the total internal reflection to occur. So for total internal reflection to occur, the angle of incidence must be greater than the critical angle, and the light must strike or travel from denser to or hit a denser to rarer boundary. Like light is moving in a denser medium and it meet a rarer boundary or a less optically dense medium. And the angle of the incidence should always be greater than critical angle. So the light must strike denser to rarer boundary, and angle of the incidence must be greater than critical angle. So these are the two conditions for a total internal reflection. A ray of a light is incident at the end of a glass fiber and refracted as it entered. Explain why the light refracted as it entered the glass. So what is the reason for that? Refraction means property of a light or property of a wave to change speed when travel from one medium to another. So why the light or the wave refracted or slow down it enter? Because the refractive index of a glass is more than air. So when or glass is having a more high density or more density as compared to air, that is the reason the light is slightly refracted. Like they're mentioning here, this part, that when this light entered from air to glass, like this is an air and this one is a glass. So when the light enters, it refracts. Refraction means it's not about every time change in direction. It can be in terms of, it is always in terms of change in speed. Direction can change, but the speed is always changing. Direction may change, may not change, depending on whether it is passing along the normal. So a ray of a light is incident on the end of a glass fiber and refracted as it entered the glass. Why the light is refracted, it entered the glass. So because glass is having higher refractive index, so it changes the speed of light. And when the speed of light change or speed of wave change, you can use the term light or you can use the term wave as well. So due to change in speed or due to change in direction, both are refers to refraction. But speed always changing, direction may change or sometimes it may not change. The diagram shows ray of a light being totally internally reflected at one side of a fiber optic, and the refraction and then refracting as it leaves. As you can see, it is refracting as it leaves. The angle of the incident at a boundary between the glass fiber and the air is equal to the critical angle. So this angle is refers to a critical angle. Critical angle means the angle of incidence for which the angle of refraction is 90. We call that as a critical angle. Determine the angle theta between the emerging ray and the normal. So we want to determine this angle. And so we want to determine this angle by using the figure. We have the refractive index of the glass. We have the, because here refractive index, because it is entering the water, and this is the refractive index of the air. So first what we will do, we can work out the critical angle. First, we can work out this critical angle. We have the formula n1 sine theta 1 is equals to n2 sine theta 2. So we can work out the critical angle. We determine the theta between the emergent ray and the normal. But first, because C is also there, we have to work out that. So first, we are taking an interface moving from glass to air. So the angle of the refraction will be 90, because this, as I mentioned, it is a critical angle, so this angle will be 90. So this one is refractive index 1, which is 1.5, and theta 1 is equal to critical angle. Refractive index of the two is 1, and theta 2 is equal to 90. So we'll use a formula to work out the critical angle, that n1 sine theta 1 equal to n2 sine theta 2. And this is when it is moving from glass to air. So n1 is 1.5 sine C, n2 is 1, and sine 90 is also 1. So this will be 1. So sine C is equals to 1 divided by 1.5, or C is equals to sine inverse 1 divided by 1.5. So this will give us the value for critical angle. So this will come out around 41.8 degrees. Why we need this critical angle? Because we'll use the same formula here, but once I identify the critical angle, as you can see here, this is 41.8. We worked out. So what will be this angle? As these two angles will be same, like if I work out this angle, the other angle, if I say this is A, so this will also be A. As there's a reflection happen, and when we work out this angle A, so the other angle will also be A. So what we can do, we work out the critical angle, which is 41.8. And because the light is reflected here, so this angle is also 41.8. If this is 41.8, how much is this angle? So how I can work out, it will be 90 minus 41.8. I'll work out this angle A. And the angle A will be same as the angle of incidence from glass to water, because we have to use the same formula from glass to water. So n1 sine theta 1 equals n2 sine theta 2. So n1 is the refractive index of a glass, which is 1.5 sine theta 1. So what is sine theta 1? Sine theta 1 is this one, because moving from glass to air. So how much is this angle? How we can work out? As we know, this will be, A will be 90, because sum of 41.8 plus A is equals to 90. This is the total angle is equals to 90. So 41.8 plus A equals to 90. If I need A, so it will be 90 minus 41.8. That is equals to 48.2. So A equals 48.2. So if A is 48.2, so this angle is also 48.2. So this will be sine 48.2. Refractive index of the water, that is 1.3. And sine theta 2, like this emergent angle, we don't know, ray of angle theta between the emergent and the normal. So we just simplify 1.3, will divide it, and we'll take a sine inverse of this answer. So 48.2 divided by 1.3 is equals to sine theta 2. And we'll take a sine inverse of this to get the theta. of the emergent, which will come out as 59.3 degrees. That is theta 2, or the angle at which the ray emerge out from optical fiber or the glass to water. Is it clear, this question?
Yes.
So we use the same formula. The reason why we work out critical angle first, so that we can find this angle. That's the reason we worked out the critical angle first. In question 4, the photograph shows an iceberg. A beam of a light from a sun travels through top layer of this ice and is incident on an air bubble is there, as you can see, like the trapped air is there in this. The diagram shows the path of a two rays within the beam, ray A and B. So you can see ray A and B are there. Diagram is not to scale. The refractive index of the ice is 1.3. We have to calculate the speed of the light in ice. So how we can work out the speed of the light in ice? Again, we have the formula n1 sine theta 1 equals to n2 sine theta 2. As it is moving, a beam of a light is there from the sun, so it is moving. The speed of a light in air is 3 exponent 8, so n1 sine theta. But we don't. We want to work out the speed, so n1 into v1 equals n2 into v2. The refractive index of the air is 1, and speed of a light in air is 3 into 10 to the power 8. Refractive index in ice, that is 1.31, and speed in ice we don't know. So it will be 3 into 10 to the power 8 divided by 1.31. So when we divide, this will give us the speed in the ice, which is 2.29 into 10 to the power 8 meter per second. This is how we work out this speed. Explain why ray B follow the path shown as it enter the air bubble. So for ray B, it is moving like enter the air bubble. You have to show why it follow this path A. So here, the first one, the angle of the incidence, this angle of the incidence, this is the angle of incidence. This angle of the incidence is less than the critical angle. So if this angle of incidence is less than critical angle, it refracted. But for ray A, you can see why a reflection occurs, because this angle of the incidence is more than the critical angle. That's why the ray of the light is reflected. So the angle of the incidence is less than the critical angle for ray B. So it refract away from the it refracted, and moving from ice to air, from where it bent, as you can see, like this is the ice and this one is air. So moving from ice to air, as the speed will increase, so it will bend away from the normal, like the angle of refraction will be more than angle of incidence. So here, why it follow the path as shown. The first point, the angle of the incidence is less than critical angle. And the second point, that the speed of the light increase from ice to air. So as a result, it will bend away from normal. These are the points which you should mention, explaining why it took path B. Then ray A is totally internally reflected at the surface of air bubble. we have to determine the minimum size of this angle theta. So when we want to determine, basically we want to determine the critical angle, because at around critical angle, the minimum size of this means we need the critical angle. So if this is a critical angle, when we talk about this critical angle, so in that case, the angle of refraction will be 90. So whenever the question is there, determine the minimum size of the angle of incidence when the light is reflecting, total reflection, it means they're asking for critical angle. So we'll use the formula n1 sine theta 1 equal n2 sine theta 2. N1 is a refractive index of the medium, that is because it is moving from glass to air. So refractive index is of glass 1.31. That is theta or critical angle. Refractive index of air is 1, and the angle of refraction will be 90, as we want the minimum value for this. So we simplify sine theta is equals to this sine 90 is 1, so 1 divided by 1.31, and then theta will be equal to sine inverse 1 divided by 1.31. So when we take a sine inverse, it will give us 49.8 degrees. That is the angle at which the light is like the angle of the incidence for which the angle of refraction is 90. Is it clear, this part? How we determine this minimum value for theta? It means they are saying if this was a critical angle, the angle of the refraction will be, or light will travel at an angle of 90 from the normal. Is it clear, this part?
Yes.
Another question. Diamonds are widely used in jewelry due to their ability to sparkle. Sparkling is caused by reflection of a light inside a diamond. Like due to multiple reflection, it sparkles. When used in jewelry, diamonds are cut to an like their specific shape is there. The diagram shows a path of a ray of a light as it passes through a cut diamond. So this is a path or a passage of a light. When it is moving from air to glass, it bends towards the normal because speed is increasing. Then it undergo a total interreflection. As you can see, the angle is at 57. Then it further undergo a total interreflection. It means the angle of incidence is more than the critical angle. And then it goes out without changing the direction because it is passing along the normal. That's why it leaves. Explain the path taken by ray of a light when it is incident on the diamond air interface at X. We have to explain here. And your answer should include a calculation. Refractive index of a diamond is 2.4. So what we'll do, we'll work out the critical angle first, and using the critical angle, we'll mention, like we'll compare this angle 57 with the critical angle. And it will be obvious that this angle 57 will be more than the critical. That's why it will undergo a total internal reflection. So we will show by calculation. We have the formula like this one is a diamond and air. The refractive index of a diamond is 2.4. For air, it is 1.00. And we'll work out the critical angle. So leave it 57, like example, if this is C. And the critical angle, so the angle of refraction will be 90, means ray will go like this. So first we will work out the critical angle for this diamond. We have the formula n1 sine theta 1 equals n2 sine theta 2. N1 is a refractive index. It's moving in from diamond to air, so 2.4, and sine theta 1, which is a critical angle, don't know. Refractive index of air is 1, and angle of refraction will be 90. So sine C will be equal to 1 divided by 2.4, or we'll take a sine inverse. of 1.24, 1 divided by 2.4. This will give us the critical angle. So the critical angle in this case, when we take sine inverse of this, will be 24.6. The critical angle is 24.6, and when you see this angle, you can see that this angle is 57. Like this angle is more than the 57 degrees more than the critical angle. That's why the light will undergo a total internal reflection, or angle of incidence more than critical should undergo a total internal reflection. Then zircon is a popular, cheaper alternative to diamond. The refractive index of diamond is 2.4, where zircon is 2. Explain how a higher refractive index causes diamond to sparkle more than zircon. So basically what will happen, higher refractive index means smaller critical angle will be there. Smaller critical angle means for greater range of angle of incidence, the reflection can take place. Because the refractive index and the critical angle, we have n is equals to 1 over sine c. So if the refractive index is high, the critical angle will be small. If critical angle is small, so for a smaller angles, multiple reflection can occur. So higher refractive index will have a smaller critical angle. As a result, there will be more reflection. That's why the diamonds sparkle more than zircon. And the refractive index of a transparent material is measured using the 20-degree prism. A ray of a light is incident, which is perpendicular to one face which passes. The angle of refraction R is there as it leaves. Can be measured by making a suitable calculation. Suggests whether it is possible to distinguish between a diamond or a zircon using the protector to measure the angle. So using angle of refraction, can we identify whether it is a diamond or zircon? Look, this is a 90-degree prism, so this is 20. This will be 90. So 90, and this will be, because the total angle is 180. So this is 20, 90. So remaining will be how much? 110 is there. 110 minus 180. So this is 70. This is 70. The angle of incidence will be 20. So what we will do by our calculation, we'll work out. So this is 20. So we'll use the formula n1 sine theta 1 equals n2 sine theta 2. So we'll put a refractive index of diamond and refractive index of air and angle of incidence 20 and work out the angle of refraction for diamond and angle of refraction for zircon. And we'll compare. If the angle difference is more, then we can use a protector to work out the difference. Like if one case angle is 43, another way 55. So we can work out or we can measure this angle by using a protector. If the angle was very small, like 0.1 or 2 degree difference, then we cannot use a protector.